Now that we know how to construct an ellipse using affine transformations, let's take a look at conjugate diameters of an ellipse. Affinities preserve the conjugation of diameters. This means that conjugate diameters of a circle are transformed to conjugate diameters of an ellipse. In an ellipse, two diameters are conjugate when the tangents of the ellipse in the endpoints of one diameter are parallel to the other diameter. So in a circle, that would be a pair of orthogonal diameters. First, we define the major and minor axis of the ellipse. We then construct the big circle and the small circle, and also define the other points on the axis. Now we randomly choose a point P1 on the bigger circle. We connect this point P1 to the center, and where the radius intersects the smaller circle, we get the blue point P1. With the intersection of both rays, we get the red point P1 that lies on the ellipse. We saw the detailed explanation of these steps in the previous animation. If we extend this chosen radius into the bigger circle's diameter, we get a green P2 on the big circle and a blue P2 on the small circle. Because we are looking for conjugate diameters of the ellipse, we first need a pair of orthogonal diameters of the big circle. We already have one diameter, so now we construct another one perpendicular to this existing one. This gives us new points, green T1 and T2 on the big circle, and blue T1 and T2 on the small circle. Now we define the points that lie on the ellipse by determining the rays, as we did before. This gives us the red T1 and the red P2 that we can connect through the center to the red P1. And we also get the red T2 that we can connect through the center to the red T1. From the diameters of the circle that go through green and blue points, we now got conjugate diameters of the ellipse that go through the red points by using affinity. Now let's construct tangents to circles in the endpoints of the diameters. First in the points T1 and T2 of the big circle, and then of the small circle. Now we define the tangents of the ellipse in the red points T1 and T2 using the steps showed in the first animation. Now we repeat everything for the second diameter of the big circle and construct tangents in the green P1 and P2, in the blue P1 and P2, and also in the red P1 and P2. If we now mark the intersections of the tangents of the big circle, we can see that the tangents in the endpoints of the orthogonal diameters form a tangent square. The tangents of the small circle also form a tangent square. In the case of the ellipse, however, the tangents in the endpoints of the conjugate diameters form a tangent parallelogram. For a better understanding, let's color the small square blue, the parallelogram red, and the big square green. Now all we have to do is construct the ellipse through our red points and the endpoints of the ellipse axis. If we take a look at this animation, we can see that the angle between conjugate diameters of the circles does not change and stays 90 degrees all the time, while the angle between the conjugate diameters of the ellipse changes and equals 90 degrees only when the conjugate diameters are the major and minor axes.